Firstly, I will start with what is bucket sort, then why it is needed, then implementation of bucket sort, and then we will take one example to see how bucket sort actually works, and at the end we will analyze the time complexity for bucket sort. So first of all, what is bucket sort? So as the name suggests, it is a buckets based sorting algorithm. In this algorithm, we take some buckets, then we distribute our input data into those buckets. Then we will sort each bucket individually using some other sorting algorithm, which is generally insertion sort. Then we will merge the output of each bucket by traversing in order wise. So at the end we will have data in sorted manner. Here we are using some number of buckets. We are providing input, then we are doing some process on each bucket, and at the end we are merging the output from the each bucket. So it can be considered as divide and conqueror approach. As to sort each bucket, we are using some other sorting algorithm. In our case, which is insertion sort. So bucket sort can be considered as indirect sorting algorithm, and algorithm which is used to sort each bucket individually can be comparison based. So bucket sort indirectly can be called as comparison based algorithm. So one question here arises that if bucket sort is not a direct sorting algorithm, then why we need it? So let's take an example. Suppose we have an array of size 10, and we want to sort it using some sorting algorithm. So let's assume that we are using bubble sort whose time complexity is order of n square. So to sort data input of 10 elements, approximately 100 iterations would be required. Now let's assume that we are dividing our input data of 10 elements into two smaller chunks of 5 elements. So now and we are sorting each 5 elements individually and then merging them. So here approximately 2 into 25, which is 50. So approximately 50 iterations would be required, as we can discard the linear time which would be required to merge them. So as here we can see that work done is almost reduced by half. So that's what bucket sort is doing. So here is the implementation of bucket sort. Bucket sort requires input data to be uniformly distributed and over the range 0 to 1. So if input data is not over the range 0 to 1, then we can do that by applying this formula, which is x is equal to x upon max plus 1, where x is input data element and max is maximum element which is available in input array. So here is our function bucket sort, which is having two arguments. The first one is input array, which needs to be sorted, and the second one is k, that is number of buckets. So first of all, we are assigning a new array of k empty lists to buckets, then maximum value that is available in array to m. Then for each input element, we are inserting that particular element into appropriate bucket by using this formula, where array of I upon m would transfer our input in the range 0 to 1, and floor of k into that particular value will insert our input element into appropriate bucket. Then for bucket number 1 to up to bucket number k, we are sorting each buckets individually, and at the end we are returning concatenation of each bucket, that is bucket number 1 to bucket number k. Let's take one example to understand how bucket sort actually works. So here as we can see, we have input array of size 10, and each element is in the range 0 to 1. So no need to transform over here. And let's take 10 bucket to perform the bucket sort, bucket number 0 to up to bucket number 9. So the first step is distribution of data, and this is our original array which we will distribute over 10 buckets. For the first element, that is 0.78, 0.78 into 10, that is number of buckets, the answer is 7.8, and the floor of 7.8 value, that is 7, so we will insert 0.78 into bucket number 7. For second element 0.17, 0.17 into 10 is 1.7, and the floor of 1.7 is 1. So in bucket number 1 we will insert 0.17. So similarly, 0.39 into bucket number 3, 0.26 into bucket number 2, 0.72 into bucket number 7, 0.94 into bucket number 9, 0.21 into bucket number 2, 0.12 into bucket number 1, 0.23 into bucket number 2, and 0.68, that is a floor of 6.8, so into bucket number 6. So once we have distributed our data over all the buckets, so the next thing is to sort each bucket individually. In our case we will use insertion sort, and we'll sort each bucket. So after performing this step, this will be our buckets. So as you can see, each bucket is now having sorted data. So our last step is to merge output of all the buckets. So we will traverse buckets in orderly manner, and we'll merge output of each bucket. So we will take 0.12, then 0.17 from bucket number 1. Similarly, these three elements from bucket 2, and we'll merge them in final output, then 0.39, similarly up to 0.94. And as we can see, at the end we will have data in sorted manner. So the last thing is time complexity analysis of bucket sort. In worst case, data would not be uniformly distributed. So time complexity of bucket sort would highly rely on time complexity to sort each bucket individually, because most of the data elements would be inserted into one bucket. So in our case, as we are using insertion sort, so our time complexity in worst case would be order of n square, and in average case, to distribute data over all the buckets, it requires order of n time. Then to sort each bucket individually, it take approximately order of n square by k time, and at the end to merge for, all the output from the all buckets, it would approximately require order of n plus k time. By removing lower order terms, time complexity of bucket sort in average case would be order of n plus k, and as same, time complexity in best case would also be order of n plus k, and space complexity of bucket sort in all the cases would be approximately order of n plus k. So that's all from my side. Thank you.